Hello and welcome back to PolyToots. In today's tutorial we're going to be looking at motion vectors for image sequences, and now that I say that out loud that sounds really lame. Hang on. Hello and welcome back to PolyToots. In today's tutorial we're going to be making flipbook animations a bajillion times better, and you won't believe what happens next. I'm not very good at this. Anyway, you should hopefully be able to see the examples here. It looks pretty ordinary, but on the left we have a default flipbook animation. It's running like an 8x8 sprite sheet, so that's 64 image sequences playing one after the other. And on the right is the exact same thing, but with frame blending and motion vectors. So if I were to go ahead now and slow down the time, you should be able to see what this tutorial is going to be all about. I should also mention that both the Shadergraph and Amplify Shader versions of this, plus the texture sheet examples and everything else, are freely available over on my Patreon, and since the last tutorial was with Shadergraph, today's one is going to be using Amplify. So with that out of the way, let's get started on making all of this, and I'm going to start from the very beginning to also show you how you can generate these textures yourself, using Blender of course, because it's free and amazing. Naturally, if you have other methods of generating these textures, feel free to skip all of this, but for everyone else and myself included, let's make a smoke simulation. I promise you, it's super easy. I've got a new scene here, and unlike all other Blender tutorials, I'm actually going to keep the default cube and the camera, but I will get rid of the light, so just select it and hit X to delete. Then I'll grab our cube and I'll come up to the object menu and find Quick Effects, Quick Smoke. Now, depending on your default hotkey setup, you can either press the spacebar or Shift and Space to play the simulation. Lovely. Then I'll add in a new light with Shift A, Light, Sun. It doesn't actually matter where this light is positioned, but I'm going to press G to move it because it's, slap bang in the middle of all the stuff that we want to see. And I'm also going to come into a side view and rotate it away from the camera just a bit with the R key. Though it would be easier if we could see the timeline here though, so if you don't already have it on your window, then just come down here to the bottom left, click and drag up a new window, and change the editor type to timeline. You may have noticed that the smoke simulation is pure grey, even though we've placed it in a light source. And this is because at some point in Blender's many recent updates, the smoke simulations just stopped updating automatically, and now we have to force it to update by changing something on the domain, which is the box that I have selected. It's super annoying, and I really hope they get this fixed soon. But for now, if we just come over to the physics properties with our domain selected, we can just tweak our resolution here. And then put it back to what it was, and now when we play the simulation, our lighting information has been included, which is neat. I'm going to grab our cube again here and press Ctrl and 3, which will automatically apply a subdivision modifier to it with 3 subdivisions, and I want to apply this so it's not just a modifier, but rather those, those extra polys are for real. You can either use the little drop down or just hover over the modifier with your cursor and hit Ctrl and A to apply. I also want to mess it up a little so that our starting smoke shape isn't so uniform. To do this, I'll hit Ctrl and Tab and then switch us to a sculpt mode. You could also just go to the sculpting room tab, but I only need to do some cheeky little edits here. I'll press the G key to go into grab mode, and the F key will control the size. And I'm just going to deform this little guy until he's sufficiently blobby. Hit Ctrl and Tab again and come back into object mode. And as you might suspect, the simulation still hasn't updated, so with the domain selected, I'll come back to the physics tab and change that same value as before to force an update. To avoid repeating this like a million times throughout this tutorial, what I'm going to do is scroll down to the cache category and change this drop down to all. Now we have the ability to bake the simulation, and I recommend right-clicking this button and adding it to your quick favorites. I already have it in mind, so the option for me is to remove. You can access the quick favorites with the Q key, and you can see that I have both free all and bake all here. We can get the free all in here by firstly doing a quick bake. And when that's done, the button here has changed to free all. So again, just right click it and then add that to your quick favorites. Just realized I also have a texture bake option in here, which could get confusing, so I'll remove that for the sake of this tutorial. We'll go ahead and make our first change to this simulation, and this will be to the smoke emission rate, so it's not constantly pumping out smoke throughout the animation. I'm also going to just rename the cube up here so it makes a bit more sense, totally optional. The option we're looking for though is the Use Flow checkbox. And if I just press the I key on this, it will create a keyframe. And by default, it's enabled, so we can scrub to a later time, say somewhere around here, and then come back to the use flow, disable it, and then press the I key again to create that as a keyframe. So now if we scrub back and forth in this timeline, you can see that the flow is enabled up until it reaches a point, and then it turns off. So let's try our fancy new quick favorites here. So we'll press Q, free all, then Q, bake all, and let that do its thing. It should be pretty speedy at this point, and when it's done, we can preview that, and as expected, the smoke stops emitting at that frame. It doesn't get rid of the smoke that is already pumped out, it just stops the flow of any more coming in. So now it's time to start diving a bit more into these settings to get what we want, and what I'm aiming for is a sort of smoke pop rather than something with a specific direction, because for game development that will definitely have more use case scenarios and something really unique, I'll begin by sorting out the times, and so on the domain I need to free the bake, and then I can come down here and I'll change the baked frames end to 128. And then I'll come over to the timeline and set our playback frame to also end on 128. I'm using this number because I'm planning on dividing this by 2 later and pumping out 64 images. Think of it like pre-optimizing, like we can make a really long and interesting simulation. It could even be many hundreds of frames long, but we're just going to spit out every other frame and use shader magic to fill in the gaps. Anyway, like I said before, what I'm aiming for is more of a burst, so I don't want it to just float up. And we also need to be careful about it hitting the domain edges and creating these obvious visual walls. To deal with it floating up so fast, I'm going to free the bake and come down here to the field weights and change the gravity to something a little lower. We could even go to 0 and let some other forces drive the velocity, but there's going to be many ways to do many things with this stuff, and I recommend tinkering with just absolutely everything to get a feel for it all. The smoke is floating up a lot slower now, but it's still pretty visible, even right up to the end of our animation, and ideally I'd like it to fade out a bit, so by the time we hit frame 128, we have little to no smoke visible. And we can do that by enabling the dissolve checkbox here. It's impossible to say what the final value that I'll use here, but I'll go with 15 for now, and we can expect a lot of back and forth on this sort of stuff. Next up, we're actually going to select our emitter object, previously known as the default cube, because this has a nice setting on it called initial velocity, and what this will do is it will allow the smoke to inherit the velocity of the object itself. The main issue, of course, is our object isn't moving, so it doesn't have any velocity. Luckily for us though, we can animate it, and I'll do this in a different way to the way we animated the use flow checkbox. Instead, I'll come here and I'll press this auto key button, and when this is enabled, any change we make to this object in position, rotation, scale, it'll be keyed in automatically. So I'll come to frame 1 with auto key enabled and just press S to scale this guy down. Now I'll come a few frames over, say 6 or something, and scale it back up to where it was. Or we can click and drag on all the scale properties here and just say 1 for all of those, please. One word of caution is if you're done keying things in, just do yourself a favor and turn the auto key off, otherwise you may end up accidentally making keyframes in places where you just don't want them. I'm also going to just turn up the initial velocity strength to 2 and give that a quick bake. As you can see, there is definitely a push going on here, but it's still a little too upwardly for me. Upwardsly? I don't know. So I'm going to re-enable the auto key and move the emitter on the vertical axis so that as it's scaling up, it's also doing a little push downwards. Done it a little too much, but it's always good to see that your actions have direct results. So I can just come back and edit the positions again with auto key on and try to make it not so snappy. That's a little better. We can play with this until the sun goes down and back up again, but let's move on to some other details, like how the smoke is hitting our domain box, which we definitely don't want. So we can scale the domain up to give ourselves more room. And while I'm here, I'll also select the camera and hit Alt-R and Alt-G. This just resets the position and rotation to 0. It's the same as using the options in the toolbar here to do it. And now I'll move our camera backwards on the Y and rotate it to face our smoke. You can always use these other transformation gizmos if Blender's style of doing it isn't doing it for you. If we press the little camera icon here, or numpad 0 on your keyboard, we'll see through the camera's lens, and I already know that each of our images needs to be square, so over in the output properties we'll change the resolution to 256, which may seem a little low, but remember we're combining 64 of these suckers into like one image. One last thing for the camera is if we come into the View tab, we can select this option to lock the camera to view, meaning that if we navigate around the viewport, it will move the camera with us. Which is neat, but I'll do it the old-fashioned way, and with the camera selected, I'll press the G key and then whatever axis I wish to move it on. I find this to generally have less accidents than locking the camera to the view, but you do you, you know? I'm not here to yuck anyone's yum. So anyway, back to the actual simulation. I'll rebake only because we scaled the domain and it's made everything a bit weird. And if I scrub through the timeline, I can tell that I would like the smoke to last a bit longer, so I'll increase the dissolve to about 20 and we can check that out. I think it's time to start adding in a little randomness as well, so I'll add in some vorticity, which you should be very cautious of using. Like, you definitely want to be on the lower end, otherwise everything just splatters everywhere. We'll also enable noise, and for now leave that as the default. Another little bake to see how it's progressed. The main thing I'm seeing here is, because of our initial velocity on the emitter, we're getting a good amount being pushed down, but there's still plenty of room up top for the smoke to spread to. So I'll add in a force to help with this by pressing Shift A, force field, and select wind. There's really only a few settings to tinker with on this force, but the main thing I want to pay attention to first is the min and max radius. Because without it, it will just grab all the smoke and try to push it upwards. I don't want that, I just want to grab some of the top and move it more up. Other than that, just play with the speed and the noise until you finally get something that works. It can take a few tweaks and rebakes, which is why it always pays to not crank up your simulation subdivisions too early. So I think we've got something now that I think is workable. The randomness is still underwhelming as it rises up, but rather than messing around more with the wind force, I'm going to add in a whole new one called turbulence. And for this I'll set the strength to 2 for now, and the scale to 1. That's actually pretty nice, but it's just affecting too much. So much like the wind, I'll enable the max radius on this, so it mostly grabs the top areas. And then the same old story of baking, tweaking, baking, tweaking. At this point I think I can say that the smoke is good enough, so I'm going to duplicate our emitter with Shift D, then right click to drop it back to where we got it from. And I'm going to start scaling it down, which I need to do with auto key enabled and on the existing keyframes, since that data already exists. The reason I'm doing this is we have the option to render fire as well as the smoke, but I find that trying to do both on the same emitter just gives me too much fire, and I much preferred the outcome of doing it this way, so that's the way I'm going to do it. So with our new fire emitter in and scaled, I'll come over to its physics properties and change it from just smoke to fire and smoke. As with everything, this will require a rebake. That is looking pretty good. The fire is properly imbued within that smoke, but it's not too overpowering. I like it. While we're here, I'm going to hide our emitters and also make sure to disable them from rendering, because we definitely don't want to include them in the renders. I'm also going to check back in with our camera view to see if I need to make any adjustments, and by the looks of our final smoke here, it seems that we can probably bring the camera in a bit, which is good news. So now I'm going to do a test render of this to make sure it's looking mostly okay before I start bumping up the simulation resolution. We can do this with Control and F12, or if you come to the render menu up here, you have all those same options. Once that's done, we can hit Control and F11 to preview the animation, and two things might strike you here. Firstly, we can probably zoom the camera a lot further in, and also there's no fire. So I don't really know why Blender lets us see a preview of the fire in solid mode when it doesn't actually exist in rendered mode, and we can access the rendered view by pressing the Z key. What I do know is the reason we don't see the fire is because of the material that's been assigned to it. By default, it really only handles the entire density of the simulation and gives it an even color. So if we come down to the bottom left again and click drag this to the right to make a new window, we can change the editor type here to Shader Editor and just press the N key to get rid of this UI on the right. Now if we select our domain, we can see the material that's applied to it, and this is what we want to edit. So let's start by hitting Shift and A, and we'll search for the attribute node and plonk that down. Make sure to give it the name heat. This isn't a random name, it's actually a value created by the smoke simulation, and we're using this attribute node to tell the shader that this is what we want to affect. Plug this into the emission color, and then Shift A again and search for color ramp. And if we just drop this on top of the existing connection, it will automatically hook itself up. Let's take a look at our smoke side by side here, and if we change the color on the end of the ramp to like an orange and bump up the emission strength, you can see that it's coming through, but it's covering everything. So we'll grab our black color and drag that up the ramp so that our smoke is, overpowering the flame. We can also increase the density of our simulation and of course make tweaks to the color of the smoke itself. Keep in mind that if we increase the density of the smoke too much, it's going to overpower the emission, so we'll also come and give that a boost. And just play with these until you get something that you like, basically. And so now if we just hit F12, so not Control on F12, but just regular old F12, it'll give us a single render, and we can see that the fire is coming through just fine. I'll also just right click on the borders of these two windows and select join and choose the left side so it gets rid of that material view. Now it is time to bump up the resolution, so Q and free all, and with the domain selected, let's change the subdivisions from 32 to 128. I realize that's the same amount of frames that we have, that's kind of a coincidence, it's not related. This bake could take a little while, not like hours or anything, but either way, I'll be back when it's done. So that was like 20 minutes, and honestly, even that was longer than I was expecting. One thing I should mention is we can speed these things up by using an option on the domain called Adaptive Domain, and that essentially tries to dynamically change the domain size so that it only needs to render what's in it. Because even for all of that blank space in the domain, we're still rendering all of those voxels. The problem though, is it can sometimes clip off your simulations in weird ways, especially if you bumped up the density on the material, and my theory for this is just that the simulation doesn't know about the additional shader boost. So what looks clear and dense to us might just be a little wisp to Blender, and yeah, I don't know, I guess use it if you want, but anyway, back on topic. It's time to render out the final animation, but first we need to enable alpha in the rendering, and we can do that over in the render properties. And I should have mentioned this earlier, but we are using cycles to render. So under film, just enable transparent, and now if we do a quick single render, we can see that it is being rendered with alpha. Next up, we'll come to the output properties, and we'll leave these as PNGs and set our output directory to something non-default. It's pretty important that you remember where, though. The very last and super important thing we want to do is not render out all 128 frames. So in the same output properties menu here, we'll change the step size to 2, and this will just skip every other frame, which is exactly what we want. So I'm gonna hit Control F12 on that and then go make myself a cup of tea. And then drink that tea and find something else to do, because this is gonna be like 30 minutes minimum probably. Okay, so that's all done, and I'll hit Control F11 now to preview the animation, and something quite unexpected has happened here. We're getting a really rapid drop-off of some of the fire, and it just looks super weird. I could skip this whole bit and only show you the fixed animation, but I think it's important to note that these things do happen, so I'm gonna have to change some things, and rebake, and then re-render until it's right. Alright, back again. Here's the new animation, and this is looking much better. The fire doesn't just stagnate in the top half and then die immediately. We're getting some extra upward movement in it too, and the way that I fix this is by changing the way that the fire emitter animates, so it starts like lower down and a bit further back from the camera. And then I also push it up to force it to, keep moving and not stay still. The other thing I did was tweak some values on the shader. I lessened both the overall density and the emission amount, and that was basically it. So now we're done with Blender, and that's like a whole tutorial by itself, but we've still got the Unity stuff left, oh boy. So an easy way to turn our image sequences into a flipbook texture is with this amazing piece of software called Slate Editor from FaceDownFX. The link will be in the description. It's free for personal or freelance use, and the other amazing thing that this puppy can do is generate motion vectors from our animation sequence. That's like a pretty key point to this whole tutorial. So go grab that and I'll carry on. So this is the Slate Editor. Its UI can be pretty overwhelming to begin with, but the first thing we'll do is come up here and go to File, New from Folder, and then obviously navigate to where we rendered those image sequences. It automatically fits it into a square, which is very handy. So from our 64 images, we've got an 8x8 arrangement. Although it has given us a texture size of 1024, which for us is not correct since each of our textures is 256. So this section would be 512, then 1024 up to the middle. So our final size is going to be 2048. We also get this neat little preview up here, and by default it already looks pretty smooth because it's doing frame blending already, which is something we'll have to build ourselves in our shader. It also has optical flow enabled. This is the other name for motion vectors. So it is on, but we haven't generated anything yet. So if we expand this window out here and select the optical flow tab, there's a lot of settings here and some are more important than others, but sometimes you can get lucky with default stuff. But if I just hit generate all now and let that do its thing, we can come up here and select optical flow to see what is generated. If you're looking at these and think they look similar to UVs, you'd be correct. You'll also notice that it's generated some info down on the last frame, and that's handy for looping effects because basically it's trying to merge back into the first frame. For our example though, we don't need that, so I'll disable the last frame with the option over there. We may need to tweak other stuff, but we won't even know what this will look like until we get the shader up and running. So for now, I'll come over to the rendering tab, change the format to PNG, and I'll specify the output directory to dump straight into Unity because we're going to be back here later, maybe. And re-rendering, so it's just easier to overwrite the files we're already going to be using. Make sure that you enable the optical flow to be exported as well. So we're in Unity now, finally, and I realize this probably looks different from the intro screen because I haven't done the intro yet. That's how time works. We need to select our flipbook render here and make sure to set the alpha is transparency option, hit apply. Now on the motion vector image that we exported, make sure that the sRGB is turned off. And I'm going to say that once more, like make sure that the sRGB is turned off, because I guarantee that most issues that people will have with their motion vector maps is forgetting to disable that. I know this tutorial is already long enough, and my poor little vocal cords would agree, but before we get started on the shader, I have to give a massive shout out to Clement Lozar. Apologies if I've butchered that pronunciation, but this guy made the Unreal Engine shader for this way back in like 2015, so it's honestly a little surprising how hard it is to find information for a Unity version, but you know, hey ho. This is basically going to be a direct port of his shader. He explains all of his stuff really well, and there was basically nothing outside of the ordinary that I had to do to get this working in both Amplify and Shadergraph. The only difference is he's created a sub-UV function, whereas we can rely on the built-in flipbook nodes to take care of that for us. And that's that really. So a major thanks to Clement, I'm really sorry about your name. This is basically all of his work, and I'm a dirty thief. Okay, back to Unity, and I promise we'll stay here until the shader is done. Probably. Blank fresh scene, and like I mentioned about 4 days ago at the start of this tutorial, there is a Shadergraph version that I've made here, which is going to be packed in with everything else, freely available over on my Patreon. But we're doing this with Amplify, so let's create a new Amplify shader, and we'll go with Unlit. It really doesn't matter, as we're not tackling any lighting in this tutorial anyway, but Unlit just seems like the simplest choice. So we'll give this a name, and then dock the window up here, and then press Shift and Space to make it all nice and big. We'll come over to the settings here and make sure we switch this to use transparent instead of opaque. Now I'll get down a flipbook node, and this is really where a lot of our magic is going to happen, and we'll also make a vector 2 here by pressing the 2 key and clicking. Make sure it's a property and call it rows, columns, XY or something like that. And we'll hook the X and Y of these separately into the flipbook's columns and rows. This just defines the layout of our image sequence, and I've set mine to default at 8x8 since that's pretty common. Next up, we'll need a texture sample node, so hold T and click. We'll just call this one Sprite Sheet and hook the UV output of the flipbook into the UV input of this. We can also go ahead and just slam this straight into the color so we can test it soon. We'll need to give ourselves some time to drive this animation though, and later on we'll handle this in the particle system, but for now we'll just make a basic time multiplied by a property setup and feed that into the time of the flipbook node. I'll also come up here and set a directory for the shader like a good little artist, and then we'll give it a save just to see something in action. We're eventually doing all of this on a particle system, but for testing's sake, let's just stick in a plane for now. And then right-click our shader and create a material from it. And then slap that material on the plane. Obviously, we're missing a texture, so go and find that and then smash it into where it needs to go. So that's stick in a plane, slap on a material, and smash in a texture. These are the correct terms. So that's about what I expected to see. And we'll go ahead and hook in our alpha just to make sure it's working. And then I'll also disable the shadow casting from the shader itself. At the moment, this is just a basic flipbook, like there's nothing fancy, and this is made even more evident if we slow the time down. You can see it's all like, you know, chugga 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 chugga. I'm not sure what that sound effect is. Maybe a train breaking down. I'll let you decide. There's basically just two things that we need to do in this shader, and they both have equal importance in terms of how we build it. Like, we definitely want frame blending, and we obviously need to distort the UVs with motion vectors. So let's just do it all at the same time. We'll start by duplicating our flipbook node and hooking the vector 2 back into the rows and columns of this. And we'll also hook in the time node, but first feed it through an add node with a value of 1. You don't have to actually put a float down for this, you could just put the 1 in the add node itself, but I find it's nicer visually to do this. And what we've just done here is to tell this second flipbook to start one frame after the previous one. Next up, we'll dehook our sprite sheet texture sample and bring in a new one. This will be the texture for the motion vector, and we'll plug the UVs of the flipbook into this one instead. We'll also duplicate this texture sample, but change its mode from object to reference, and then give it the reference of the motion vector texture. The motion vector texture. There we go. Since we're dealing with UVs as a texture from this point on, we will need to use a component mask so that we're only outputting the R and G channels, because UVs only contain 2 channels of information, U and V. 2 letters, 2 channels, checks out in my books. We'll also copy this and feed it into the referenced texture as well. Now we need to multiply both of these by 2 and subtract by 1. And the reason we're doing this is because we're using the flipbook to drive motion vector textures, which are now going to be used as our new UVs for the sprite sheets. So for this to make sense, we have to basically remap the UVs, otherwise they'll be offset and will distort the wrong way. I like to think of it as a UV's pivot point, but then again I like to think of a lot of things that might make no sense in reality. Now we'll throw down 2 more multiplies on the end here, and this time we need to introduce a fraction or fract node. And this is where we start introducing the frame blending, in that one of these flipbooks will flash at like, 0, 1, 0, 1, and if we use a 1 minus for the bottom nodes, it'll be like 1, 0, 1, 0. I'm almost positive there's a better way to explain that, but I feel like I've been trapped in this tutorial for eternity, so my brain ain't doing so good right now. We also need to hook our time setup from earlier into this fract node. That's pretty important, otherwise the fract doesn't move at all. If you are tired of multiplies, I've got bad news for you. We're going to add 2 more into this chain, 1 up top and 1 down below. And we'll hook in a new float property for this, which will be the amount that we distort the texture from our new UVs. This value needs to be pretty low, and we could throw in some remaps or divides to give ourselves something nicer to work with on the material, but no need. Just, keep it low, like 0.003 sort of low. Now for the top chain only, we'll throw in a subtract node, and we'll subtract this chain by the original flipbook UVs. And don't be like me here, like the order of the subtraction is actually the opposite of what I've done, and what's even worse is I made this exact same mistake the first time I built this shader. We'll copy this sprite sheet texture too, and change it over to reference like we did with the duplicated motion vector. And for this, we're going to place an add node. And similar to above, we'll add the flipbook of this chain into the end of the chain. And then feed that into the UVs of our duplicated sprite sheet. Now we'll blend it all together with a lerp, which is essentially just choosing 2 things and then deciding how much they blend with each other. So our 2 things are the texture sheets, and I'm using RGBA output for this, whereas normally we would just do the R channel, but that's because I plan to do some cheeky stuff later. What I will do for now is use a component mask after this lerp and tell that to only use the R channel. It makes no sense to do this now, but just wait. We'll use our time fract setup here, is the blending for this loop. This is what makes the frame blending actually happen. If you remember my amazing 01011 whatever ramblings, it's just opposites. That's what I'm trying to say. Tide comes in, tide goes out. You can't explain that. So now we'll plug this into the color output and finally go see what a mess we've made. This is not right, and it's because I've got my subtract node the wrong way around. So a quick little fix to that, and now we can see what it's actually supposed to look like. It's pretty good, a little rough around the edges, but if we do that same lerp setup as before, but this time using the alpha channel, then we should get that sorted out pretty quick. This looks about right, but we do still need to actually put in our motion vector map, and as soon as I do, you will see a world of difference, or like a country or a small village. This is actually looking a lot better than I thought it would. You can still see some oddness right at the start, and this is mostly because the changes in our simulation shape are too big, too fast, and as cool as frame blending and motion vectors are, there is still like only so much in between frames that they can patch up. So, you know, major differences like this can often be obvious. But that said, this is like 1 FPS, and chances are you'll never slow your particle down to 1 FPS. I actually think the motion vector we got out of the Slate Editor right at the beginning is already passable. I had planned to go over some settings to improve it, but at this point we've got to be competing with like the Lord of the Rings trilogy in terms of runtime, so let's just skip straight to converting the shader into working with particle systems. The first thing I'm going to do is bring our motion vector and spritesheet textures into the Amplify editor here so we can preview what they look like. And the reason I'm doing this is we're going to mess around with the colors, so we need to see what sort of values we're working with. This is one of the 2 reasons why I split the lerp with that component mask. So let's feed this into another lerp as the alpha, and then we'll get ourselves 2 color nodes, one for smoke and one for fire. Don't forget to enable HDR on the fire one, that's pretty important. You can see if we give these some colors, it's just crazy town in the preview, and I'm trying to use this setup to grab certain grayscale ranges and recolor them. So I'll add in a power node after our component mask and tweak that until the values look about right. I do think the preview is lying to me here though, so I'll go with a value of 3.5 and then I'll see what it looks like. Yeah, so I mean it was absolutely lying. Shame on you, little shader. So that actually had very little to do with the particle system specific setup, but we will use it, I promise. To move on though, we're going to replace this time setup we've got here with a vertex text chord node set to a float 3. And we do this because U and V are already occupied by default, whereas the W isn't doing anything. And we can use that value on the particle system later. So anywhere the time setup was in before, just replace it with the W output of this, and that's it. Next up, we'll come over to the fire and smoke colors we'd made, and we'll reset the fire color to white, but leave the HDR value as is. Then we'll multiply this with a vertex color node, and this will allow the particle system to make changes to this color. Similarly, we also want to control the alpha, so we'll use another vertex color node and multiply our alpha with the alpha of this node. Easy peasy. So now if we commit this, you'll see that our simulation has stopped working, which is also a lie because in theory it's working even better now. So let's delete that plane and chuck in a particle system instead. You'll have to forgive me for not going over the specific settings here, but it's been a little while since I've told anyone to go over to my Patreon where they can get a free Unity package that has this particle system in it, you know, if they wanted to see how it was set up. I will of course mention the important bits, like making sure we put our material on this, and from there we can immediately test both the color and the alpha, which are now controlled with the particle system itself, which is very cool. But we are missing a pretty vital ingredient, and that's motion. What we need to do is come down to the renderer category and enable custom vertex streams. Now we can add in a custom1.x. When this is in, you can see that it's already telling us that UV text chord XY is in use, and our custom1.x is going to be using the Z. This is the equivalent of UV and W, and if you remember, we're using W to drive our time now. So we need to come up here and enable custom data, and we'll change it to a vector. We only need a vector 1, and as you can see if we scroll through here, it starts to change the frames. So we want to change this to a curve so that it can change the frames by itself. And we'll set the max number to 64, although I'm pretty sure I changed this to 63 later, since 0 to 63 is actually 64, because 0 still counts, you know? So the reason that this is good to do is we can basically control the speed of this flipbook with the lifetime of the particle itself. And this has many applications aside from just cooler looking VFX. You might have instances in your game where some slow motion comes into play, at which point any regular flipbooks are going to, chugga 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 chugga, whereas this bad boy is going to be smooth sailing. So that almost wraps this up, but just as one final push so that we can all celebrate 2 birthdays while watching this tutorial, I'll show you the second reason for why I was using RGB output on the sprite sheets and splitting it to the R channel afterwards with a component mask. It's this. A cheeky little solution to not having any lighting info is to multiply the RGB of our render over the top. This often makes VFX artists do a little sick in their mouth, but if you're in a pinch, I say go for it. There's also no way anyone has actually made it to the end of this tutorial anyway, so my sins should be safe. So that is it. I've done enough talking for all of us, so I'll just say a big thank you to anyone who supports my channel in any shape, way, or form, especially if any of those shape, ways, or forms are over my Patreon, where all of this stuff is free. But if you wanted to fuel my veins with a free coffee for a month, I am all ears. So as usual, thank you very much for watching, all 6 of you at this point, and I will see you in the next one.